Alright, hi guys. This is Monday's walkthrough, and we're going to talk about two-step equations. So go ahead and take out your notebooks and get ready to take some notes, okay? Alright, so here's step number one, or problem number one, I should say. We have 2x plus 5 is equal to 25. Now, our whole goal with this is to isolate the variable. Now, the variable is attached to something, and that's 2. However, in order to get to that 2, we need to start furthest away in that expression and then work toward our x, our variable in this case. So our first step is we're going to start with addition subtraction first. Now, I know that seems a little bit counterintuitive because we talked about PEMDAS and we talked about how we would start with multiplication division first. However, since we're using inverse operations, we're starting kind of inversely. So we're going to start opposite with addition subtraction. So in order to do that, guys, we're going to address the positive 5 first. In order to get positive 5 away, I'm going to have to subtract 5 from both sides. So when I subtract 5 on the left side of the equation, I get 0, but when I subtract it on the right, I'm going to get 20, and I'm left with 2x equals 20. Now, here's the problem. I have 2x equals 20. X is still not isolated, so I'm going to have to do step 2, and that's addressing our inverse operation of multiplication division. Now I've reached a point where I can address that multiplication division. And here we have multiplication because 2 times x is multiplication. I'm going to use division, and I'm going to divide by 2 to get x by itself. Remember, our goal is to get x by itself. When I do that, I get 1. I'm going to do the same thing on the right side of my equation, and I get x is equal to 10. Now, step 3 is super crucial. Do not forget step 3. You're going to take it and plug it back into the equation. So I'm going to take my variable, which in this case we said was 10, and I'm going to substitute it for x. So in this case, I have 2 times 10 plus 5. Is this a true statement? If I simplify, yes it is. Okay, so 10 is my solution. Now let's look at number 2. We have 6 plus 2x equals 10. Pretty simple, but this way it's kind of reversed. Still the same situation. We're going to address addition subtraction before multiplication division because we're kind of working our way into the variable. So what I'm going to do is subtract 6 from both sides. 6 minus 6 is 0. 10 minus 6 gives me 4. So I'm left with 2t equals 4. Now, step 2, we need to address the multiplication division part. So we do have a problem. We have 2 times t. So I'm going to use the inverse operation of division, and I'm going to divide by the coefficient of 2 on both sides, and I get t is equal to 2. Now, remember, anything divided by itself is just 1, and this t, even though it's just t, there is an implied 1. Just keep that in mind. Now I'm going to take 2 and substitute it back into our equation. So 6 plus 2 times 2 equals 10. Is this true? 6 plus 4 is equal to 10. 10 is equal to 10. That is a true statement. Okay? All right. Ooh, we've got a doozy here. We got a fraction. I know how much you guys love fractions. All right. So we're going to start with inverse operations of addition subtraction. Still keeping it the same. So I'm going to address that 18. That's near k over 3. So I'm going to subtract 18 from both sides. If I subtract 18 on the left, there's nothing left except for k over 3, and 20 minus 18 would give me 2. So I'm left with k over 3 is equal to 2. But some of you are asking, well, Miss D, what do I do with k over 3? Well, that's pretty simple. K over 3 is a fraction, right? All fractions are division, you're right. So the opposite of division is multiplication. So also remember, there is an implied 1 in front of k. So when I multiply, I'm going to multiply by the reciprocal of 1 over 3, right? That's my fraction, because if I simplified 3 times 1 and 1 times 3, I get 3 over 3, and that's just 1. So these cancel each other out, and I'm left with k. But don't forget, you need to multiply by the reciprocal on the right side as well. 2 is a whole number, which we can write as a fraction, and I get k is equal to 6. Now I'm going to take 6 and substitute it back into our equation. I get 6 divided by 3 plus 18 is equal to 20. Is this true? 2 plus 18 is equal to 20. 2 and 8 is equal to 20. Yes, it's true. All right, question 3. This one is a little bit of a doozy as well. Now, I know I said that normally we do addition subtraction first, and then we address multiplication division, but look at the problem. What situation are we dealing with here? We're dealing with a fraction. Now, the number that's farthest away from the variable in this case is 7, and that's our denominator. In order to get it as a normal expression of just s minus 35, we need to get rid of the fraction piece first. So we have to do multiplication division first, okay? So if you look, step 1, we're going to multiply by the reciprocal. So 7 is on the denominator. It's hard to think that there's an implied 1 in the numerator, but there is. So if you look at 7 in the denominator, if I multiply it with 7 in the numerator, I get 7 over 7, meaning 7 divided by 7, that's just 1. So these technically cancel, and I'm left with 1, but we know that anything divided by 1 is just 1, so I can get rid of that 1. But don't forget to do the same thing on the right side. So we multiply by 7 over 1. Remember, 9 can be written as a fraction over 1. So I get s minus 35 is equal to 63. Okay? Now, s is still not isolated. That variable needs to be by itself. So I'm going to take that and now isolate addition subtraction. This is an easy one-step equation, so you know we're going to add 35 to both sides, and that leaves me with s is equal to 98. Now I'm going to take 98 and plug it back into our equation. So 98 minus 35 over 7 is equal to 9. This is true. I get 63 over 7 is equal to 9. That simplifies to 9 is equal to 9. So yes, it's true. All right. We got another doozy here where we have to address multiplication division before addition subtraction. Now again, I told you we're going to work from the outside in to get to the variable. If you'll notice, t is in parentheses with 37. 37 is closer to t than 9 is. So we need to get 9 away from t and 37. So in order to do that, we are going to divide. Now, why are we dividing? Think about distribution. That 9 is in front of the parentheses, right? So when I have it in front, I'm distributing it to both terms, t and positive 37. That means I'm multiplying it. So in order to get 9 away, I want to divide by 9. So that gives me 1, but also divide by 9 on the right. So I'm left with t plus 37 is equal to negative 10. Keep up with your signs. Do not forget. Negative divided by a positive gives you a negative, okay? So I'm going to take that expression, and now we can do address addition subtraction, which is the simple part. So I've got t plus 37 is equal to negative 10. I'm going to subtract 37. That gives me 0. I'm left with just t on the left. Then I'm going to subtract 37 on the right. That gives me t is equal to negative 37. Remember we discussed about this. These are your addition rules if you're subtracting. So say you owe someone $10 and now you owe them $37 more. Guess what? You're still in debt $47, okay? Now I'm going to take negative 47 and plug it back into my equation. 9 parentheses negative 47 plus 37 in parentheses is equal to negative 90. Is this true? So negative 47, remember we're going to do order of operations. If you want to distribute the 9, you'd get the same thing. But I'm just going to do order of operations. So I'm going to add negative 47 and 37 together. I get negative 10. 9 times negative 10 gives me negative 90. So that is true. All right, go ahead and pause the video and then complete these questions. First 5 get candy. All right, so hopefully you guys paused it and you did it, and now you're just reviewing your answers. For number 1, you should have gotten -9. Remember, once you get your variable, plug it back into the equation to see if 22 is what you got, okay? Number 2, you should have gotten -3. Again, plug it back into the equation. Number 3, you should have got 70. Plug it back in. What I want to talk about with this one is keep in mind that does say plus -97. It doesn't matter that there are 2 signs in front. What kind of 97 is that? It's negative. So the opposite of -97 is positive 97. So when you add positive 97 on both sides, you're left with positive 7 on the right side. Okay, so u over 10 is equal to 7. Multiply by 10 on both sides, u is equal to 70. And then lastly, number 4, we got x is equal to 9. Wonderful. First 5 people got candy. See, Miss Zelinsky even gave you virtual big candy. All right, I'm impressed. All right, guys, that's the end of Monday's walkthrough. Believe in you, I do. I really do. I'm impressed with how well you guys have been handling digital learning days. So we look forward to another great week. Have an awesome day.